Merry Christmas to you once again. This will be my second gift for you today, being Christmas, the 25th of December. I'm going to be teaching you polynomials. Now, if you have not seen the video, my first gift, that was on electrochemistry, voltaic, and galvanic cell, do also see that video. That was my first gift for you to you in Christmas. And then before the end of this video, I'm going to be giving you a bonus or an additional information or a tip, you know. All right. So by the end of this video, you should be able to understand polynomials, work with them, solve questions, especially those of you that are preparing for external exams, WAEC and UTME. So I promise you by the end of this video, you'll be able to do well in those exams, provided you stay until the end. And I told you I'm going to give you a bonus at the end, so do wait until the end. All right. What is polynomial? Or what is a polynomial? Or what are polynomials? Now, you see, for formal definition, we can define polynomial as let's say a polynomial is an algebraic expression that contains in a finite number of terms. Do you understand? And with each term being an integer, being a constant multiple, a constant product of a coefficient and a variable with a variable raised to the exponent raised to a non-negative or a positive, a non-negative exponent. All right. So that is a formal definition of an algebraic a polynomial. So it takes the form ax raised to power n. Now this is the constant, that is the coefficient which is multiplied by the variable x, and the variable x is raised to a non-negative exponent. So this plus ax raised to power n will reduce by 1. Now look at this. One thing you will notice here is that this n is the highest power. Every other, the first term usually carries the highest power, as the first term usually contains the variable carrying the highest power. All right. So what I'm saying invariably is that the next terms here, we have less powers. So this will be like a1, a sub 2, because they could be different. Is that okay? A sub 1, a sub 2, a sub 3, x raised to the power n minus 2, plus a sub 4, x raised to the power n minus 3, plus dot, 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 plus a sub whatever, maybe n. Okay, let's use another number because it will be any amount of number. Well, usually and sometimes. Usually the same number. I'm going to talk about the types of polynomials with respect to their number. So we have a raised to power a sub m x raised to power 0. So at this point here, x to be raised to power 0, that is, it's only the constant that we have. So the constant ends it. So this is what we mean by this definition. Do you understand? Each of those terms are constant products of the coefficient and a variable that is raised to a non-negative exponent. So that's what a polynomial is. All right, now a polynomial can be divided based on number. We have the simplest polynomial is known as the binomial, and the binomial is the one that contains two terms. So for example, if I said x plus 1, this is a binomial. A plus b is a binomial. All right. Now, then the second is a trinomial. and you see and on like that. The simplest rather is a monomial. Sorry, a monomial. A monomial is x. So the second is binomial. The third will be a trinomial. Sorry, I just remembered try 3. Huh? So monomial. So monomial could be x, then x plus 1. Then trinomial will be something like a quadratic expression. A quadratic expression, for example, ax squared plus x minus 1 or plus 1. That is a trinomial. Do you understand? Then we have a quadrinomial. A quadrinomial, number 4. So you see x to the power 4 plus x to the power 3 plus x to the power 2 minus 2x plus 1. So how do we know their numbers? How do we know their names? It's just by counting the number of terms we have there. So here 1, 2, 3, 4 terms are there. We call it quadrinomial. You understand? Here we have 1, 2, 3 terms are there, and we have trinomial. And A and B, just 2 terms are there, and we have a binomial. Then we have we also have one in which one term is there that we call a monomial. Excuse me. All right. So, and like that, we have them on and on like that. Until we get to 10, we have decanomial. Don't know what that is, but basically these are the major forms of polynomials that we have. All right. At least in most cases, these are the ones we work with. I'm going to be linking the video on systems of equation below. Do well to see that video because we dealt with many things on this that are involving polynomials, different types of polynomials. Okay, now let's get to, we're going to be dealing with the addition of polynomials. We're going to be dealing with the subtraction of polynomials. We're going to be dealing with the multiplication of polynomials. We're going to be dealing with the division of polynomials also. Then we'll deal with remainder and factor theorems. We also deal with zeros of polynomials. Number 6, zeros of polynomials. Zeros of polynomials. All right. Now, let's start with the addition of polynomials. Addition of polynomials. All right. Now, polynomial addition is very simple. It's very, very simple. There are 2 ways I'm going to be teaching you, 2 methods in each case. So, for example, we want to do addition of these polynomials. If the question says, add the following polynomial: 3x cubed plus 4x squared minus 3x plus 1. Add to 3x squared minus 4x plus 3. Now, if you are told to add these 2 polynomials, now this is a 1, 2, 3, 4 quadrinomial, that is a 1, 2, 3 trinomial. You are told to add them. Now, if you see the degrees of the polynomials, now based on degrees, we talk about powers when we say degrees. Now, the degrees of this polynomial, this guy is in the 3rd degree, 2nd degree, 4th degree, 0th degree. Do you understand? Right. So, I mean, that is the power in which the variables are raised, or powers to which the variables are raised. So, this guy being raised to power 3, and there's no guy being raised to power 3. You add them based on their degrees. So, polynomial terms with the same degree, or that has variables that carry the same degree, are like terms. So, for example, this one is in the degree 3. There's no 3rd degree variable here, so this guy is going to be alone. 3x cubed will be alone. Then plus 4x squared. Now, this is 2nd degree. This guy is also in 2nd degree, so we add them plus 3x squared. Is that okay? There's not much with addition. It's very simple. Just arrange properly. Then minus 3x. Then here, 1st degree is 1st degree, so we have plus minus, that will be minus 4x, then plus 1, and plus 3. So what we have here is going to be 3x cubed plus this is going to be 7x squared. Then minus this will give us minus 7x. Then plus this will give us plus 4. Is that okay? And that's going to be our answer for this expression. Now, what if the question said, now, that is all with addition. If we're told to do subtraction of this polynomial, now what we're going to do is this. Now, we have 3x cubed plus 4x squared minus 3x plus 1 minus 3x squared minus 4x plus 3. Now, if you are told to subtract this expression from this expression, now you put them in brackets. You put this guy in brackets, these 3 terms. You put them in brackets because now minus is going to influence their signs. So what we have now will be 3x cubed plus 4x squared minus 3x plus 1 minus 3x squared plus 4x then minus 3. Then next, what you have is that you now follow the rule that we talked about the other time, pair them up based on their powers or their degrees. So we have this guy has no pair there, so we rewrite it. Then this guy plus 4x squared minus 3x squared. Then here we have, let's put this one, the positive first, plus 4x, then again minus 3x, and plus 1 minus 3. So here we have 3x cubed plus 4x squared minus this will give us plus 1x squared. That's plus x squared. Then plus 4x minus 3x, another plus x, and here minus 2. And that's going to be the answer. So you see, they are different, right? So that is about subtraction. And that's all about subtraction of polynomials. You see, your external exams here are not going to be tested on addition and subtraction most of the time. You'll be tested on multiplication and division most of the time. So let's get into that already. So this addition, this subtraction. Let's get into multiplication of polynomials. I'm going to start with the basic multiplication of polynomials. I'm going to start with a binomial expression. A binomial expression. Now, if you were told to, I taught you a trick. Now, I'm also going to try and link that video in the description. The video where I taught you tricks, some math tricks, and in one of those tricks, I mentioned that if you wanted to multiply something like 13 by 13, you need not carry again. That's multiply without carry. So you do something like, let's say I wanted to do 23 or 43 by this. Let's say 44. So I'll say 4 times 3 is 12. So usually you'll be told to write 2 and carry 1, right? Just trying to reach it so you see what we'll do in multiplication. So this by this. Rather than carry, you do this by this, 12. Then you write the 12 in full. Then the next thing you will do is this by this is going to be 12 again. Is that okay? So what you will do is you write it underneath. Do you understand? So that will be another 12 here. Then you now come here. 1 by 4. What will that be? That will be 4. That doesn't change. In fact, we could use a number that, but basically, you saw what I did. I did not carry anything. I just came underneath it and wrote that 12. I had 1 by 4, 4, 1 by 4, 4. And so here we add, and we have 2, this, 7, this, 5. Do you understand? So that is the trick. And that's the basis of what we'll be doing there. That's the basis of what we're doing there. Now watch this. Because of course we cannot carry letters. Is that okay? All right. Let's do multiplication basically. Multiplication. So if I said solve A plus B and A minus B, for example. Right. In fact, let's start with the simplest. A binomial times a monomial. So what you're going to do is you write A plus B times A. What you do is A times B, AB, plus A times A. And this plus is coming from just A times plus B. That will be plus AB. Do you understand? Then A times A will be A squared. And this is your answer. As simple as that. Now, what if you're now told to do A plus B times a plus or a minus 2b. In this case, I'm still going to express it like this: a plus b and a minus 2b. Keep in mind that this is just one method. Is that okay? Many of you have taught the method of doing this and coming here. Now I'm doing this other method because of people who usually find it hard to do. Do you understand? All right. Okay. So here we have 2b times this. That will give me 2b squared. But you have to keep in mind that you have a minus there. Now, so minus this times plus this will give a minus. Do you understand now? So minus 2b times this is minus 2b squared. Then minus 2b times this guy will be minus 2ab. Does that make sense to you? Good. Then we have a times b now will be, because it's plus, so it will be plus ab. So keep in mind that you will write it under that a, the one you are using. When we started with b, with this guy, we wrote our first answer underneath this place. So we are doing for a now, we write our answer under a. Do you understand? And we have a by a, then we go this direction next. A by a will give us a squared, so that will be plus a squared. And then we add them all up. Here we have minus 2b. Here we have so one of the usefulness of this technique is that it places like terms underneath each other. All right, so that you don't need to be arranging and all of that. Once you have arranged it well from the beginning, you don't need to be looking for which and which is alike. All right, so minus 2ab plus ab will give us minus ab, then a squared here. So we have a squared minus ab as our answer, minus 2b squared. All right, let me solve one more. Let me solve one that might look a little complex, even though it's not complex. Number 3, what if we had something like 2x squared or 2x cubed minus 4x squared minus 6x plus 3 to be multiplied by, so the question says multiply this guy by x squared minus 2x plus 4 plus 4. So when you have a question like this, you can do it the same way. Now, keep in mind still that I'm saying this is the first method. This is the first method. All right. So if I wanted to multiply this, I'll write the longest one on top. So I have 2x cubed minus 4x squared minus 6x plus 3. And here I have x squared minus 2x plus 4. Now I'll draw my line. All right. So now I can say this by this will give me plus 4 times plus 3. That'll give me plus 12. Plus 4 times minus 6x will give me minus 24x. Just follow me diligently. Plus 4 times minus 4 squared, that will be minus 16x squared. Then plus 4 times this guy will give me 8x cubed. Then we go here, minus 2x times this will give me minus 6x. Then minus 2x times minus 6x will give me plus 12x squared. Minus times minus plus. Is that okay? Now, minus 2x times minus 4x squared will give me, now, the degree will change again. Will now be third degree, right? So minus times minus plus still, plus 8x cubed. Remember? 2 times 4, 8. Then we have minus 2x times 2x raised to the power 3. Minus 2x times 2x raised to the power 3. That will be minus 4x raised to the power 4. Did you get that? And we'll go to the next level, which is the last here. It will probably be the last. So then we go x squared times 3x. We start from underneath x squared. So notice when we started with 2, we started here. Now we're going to the third level, come here. Do you understand? So x squared times that will give us 3x squared. And this guy times this will give us minus 6x cubed. Then this guy times this will give us minus 4x to the fourth, right? Then this guy times this will give us 2x to the fifth. I'm breathing heavily because of my health. Is that okay? So, obviously recorded. So, then we add up everything we have. So let me clean this. Okay. So we'll add up everything, and we'll have this guy plus nothing will be 12. This guy, so minus 24 minus 6, that is minus 30x. Minus 30x. Then minus 6x squared plus 12x squared. Then here, we didn't put the sign. This time that's plus. All right. So we have minus 16x, then plus this. So it's just basically this plus this 15x squared. Then minus that will be minus x squared. Is that okay? Then we have 8x cubed plus 8x cubed, 16x cubed minus this 10x cubed. Then minus 4x to the fourth minus 4x to the fourth. That will be minus 8x. Remember this plus here. Then minus 8x to the fourth. Don't forget the sign. The sign first before the number. Then here, this one plus nothing. So that will be plus 2x to the fifth. And that is the answer. That is the answer. All right, so that will be for multiplication. Let's get to the next step. The next thing, which is division of polynomials. Division of polynomials. Now, in division of polynomials, division of polynomials. Okay, so how do we divide polynomials? Let's say we wanted to use this polynomial to divide this one rather than multiply it. Let's try that. That will be example 1. 2x cubed minus 4x squared minus 6x plus 3 divided by x squared minus 2x plus 4. So basically what we want to do is 2x cubed minus 4x squared minus 6x plus 3 all over x squared minus 2x plus 4. So the simplest method of division is this. You draw your division line. So division, whatever, maybe just division shape, whatever you call it. Okay, so now come here. Now here you put the divisor. Here you put the item you are dividing, and your quotient will be here. So your divisor is x squared minus 2x plus 4. Then you are dividing 2x cubed minus 4x squared minus 6x plus 3. Now listen to the explanation. Now division of polynomial is very simple, but you can make mistakes. So you have to listen to me carefully and see the way I will do it. So all you need is pick the first element. Now this first term rather. The first term here is x squared. Now you ask yourself, what we use to multiply x squared? Just come and divide this by x squared. So you pick only the first terms. Keep that in mind. Keep only the first terms. So I want to divide that out with 2x cubed divided by x squared. Now if I want to divide this, I'll have this will take care of 3 to remain 1 here. So I will have 2x, right? So my answer is what? 2x. I used only this first term to divide this first term. That was all I did. And once I've done that, I will now use this to multiply this throughout. So once I've gotten my first question, then I'll do this. This by this will give me the same thing, 2x cubed. If you remember this technique of division that we used before when we were younger, I wanted to divide 64, for example. So I'll say 4 in 6. I'll say 1. 1 times 4. 4, right? So we'll now subtract. We have 2. We now bring down the 4. 4 in this, 6. So 6 times 4, 24. Then we subtract, then we have 0, right? So our answer is 16. So that's the technique we are using there. That's the technique we are using there. So we said you multiply this by all of the expressions here. This by this, 2x cubed. This by this, minus 4x squared. This by this, plus 8x. All right. Then you now do what? You subtract. You just follow the same technique. This minus this will give you 0. So you can just cancel it like that. So this, so minus 4. Let's eyeball the x squared. Let's just use the coefficient. Minus 4 minus minus 4. That will be minus 4 plus 4, that's 0. So this also goes away. Is that okay? Then we now have minus 6 plus 8. That will be plus 2x. Then 2x plus 3. All right. Here, this guy is at a higher power, so it can no longer divide this. So it can no longer divide this expression below. So our answer will be 2x remainder 2x plus 3. Do you understand? Because this degree is greater than this degree, so this cannot divide this. Do you understand? All right, except you want to use a fraction anyway. All right, so that's that. Now let me give us a more standard question. So now don't worry, I'm going to release a different video on this division of polynomials because there are various types of questions that you can see under division of polynomials. All right, let's do this. Let's say we said divide 5x to the 4th minus 3x to the 3rd minus plus 4x minus 2x plus 3. It says to divide this by x squared minus x plus 1. Or let's use a very simple case, x plus 2. Let's just say x plus 2. I told you to divide it by this, x plus 2. So very simply, you draw the same thing. You draw the same division diagram. Then you bring your x plus 2 here. And this guy, you bring it here. So this is the part of the board we are using. Okay. So you bring this guy here, you bring it here. Minus 3x cubed plus 4x. Okay, 4x squared. Now I wanted one where, let's remove this. 4x minus 2. So there is no square there. Is that okay? So I want to see the way to impact our answer. Okay, so here, remember I said take the first guy only, to divide this. So we want to use the first guy to divide that. What would we do? We'll say x, so we'll say 5x raised to power 4 over x. So x takes care of 1 of x here, and we have 5x cubed. So on top here we have 5x cubed. Now that 5x cubed, we now multiply this to expression. And we have 5x to the 4th first. Then 5x cubed by this will be what? Plus 10x cubed. Do you understand? Then we now subtract and draw our line. And by the time we subtract, you have that this will cancel this out. And minus this, minus plus this, that becomes minus this, minus this. You understand? That will be minus 13x to the 3rd. And we'll bring out the rest that have not been worked on. 4x minus 2. Did you get that? Now I'm subtracting. This is minus 3 minus plus. That will be minus 10. That's minus 13. Then in the next step, the same way, you use this to divide this. So now you bring out this whole expression. That will be minus 13x to the third over x again. So x takes care of 1, and it remains 2 x's. You understand? Because this thing means x times x times x. So you cancel 1, it remains x times x, that's x squared. So the answer will be minus 13x squared. So you come here, minus 13x squared. But don't forget to add the minus when you are bringing it out to divide. So minus 13x squared times this will give you minus 13x to the third also. The minus 13x squared times this will give us minus 26x squared. Then you divide, you subtract again. Minus this, minus this, that is 0. Then plus this minus this. That is plus 4 minus 26. That's plus 4 plus 26. That's what? 30. So that's plus 30. So we have, okay, now, that's my mistake there. Now, you see, they are of different degrees. They have different degrees, so you cannot add them. You cannot add them. And that's why I wanted to do this kind of question where there will be different degrees. So you see that to impact your answer in a way. So you see that this, because this guy is in degree 2, as is quadratic, this one is linear. They cannot add up. So you now come here and bring this guy down. Minus 26x squared. Okay, so minus. Do you understand? Minus will be plus. Do you get what I'm saying? Now this guy, the equal term or like term that it has on top here is plus 0x squared. Do you understand now? Plus 0x, so plus 0 minus this. That's plus 26x squared. Do you understand? All right, so plus 26x squared, then plus 4x, then you bring down minus 2. Exactly now. So you now do this again. This divided by this again. So you have 26x squared over x, and what you have is this takes care of this remaining one, then you have plus 26. So we have plus 26x. So 26x to multiply this and give us 26x squared now, then plus 26 times 2, that's 52x. There's 52x, then, yeah, that's 52x. Then we'll now subtract again. Subtract. So when we subtract this, we have 0. Do you get it? So now 4 minus plus this, that will be minus this. Do you understand? Because they are in the same degree. Do you understand now? So plus this minus this, that will be minus 4 from, if you subtract 4 from here, you get 48. That will be 48x. Then we'll bring down minus 2. Then we'll keep going. X will go in minus 48x to give us minus 48. You do the same thing, minus 48x over x. X takes care of x, we have minus 48. So minus 48 times x, we have minus 48x. Minus 48 times this, minus 96. Do you get it? Minus 96 over, you close the guy there, and you subtract them again, you get a 0. Now when you get a 0, here you now say minus 2 minus 96. Have minus 2 plus 96. That's usually 96 minus 2. That's what? 94. So our answer is what? 94. So our answer here is going to be the quotient to be x, 5x raised to the power 3 minus 13x squared plus 26x minus 48, remainder 94. All right. So that'll be it for division of polynomials. We're going to go to the next thing, which will be the remainder and factor theorem. Let me clean the board. Now let's deal with the remainder theorem. Now the remainder theorem of polynomials states that if I wanted to divide a polynomial f of x by, if I want to divide this polynomial by f by a particular monomial x minus a, if I want to divide this by this, that my result will be another polynomial q of x, which is 1 degree less than this. It is 1 degree less than the original polynomial, rather. So if I divide this with this monomial or any other polynomial, that I'll get another polynomial that is 1 degree less than the original polynomial plus a remainder, which could be a constant or another smaller polynomial, still divided by our function, our x minus a. You understand? So that is the polynomial. That is the remainder theorem. So what he's saying is that if f of x is divided by x minus a, the result should be q of, this is q of x plus r over x minus a. And what that means is that f of x, therefore, is equal to q of x times x minus a plus r, provided I multiply through by x minus a. Now, what this means is that using their units, then it means that this will be equal to this, and f of x also will be equal to r. All right. So the remainder theorem is therefore saying that if I said find the remainder when f of x is divided by, when f of x, which is 3x cubed minus 2x squared plus 5x minus 2, is divided by x minus 3. Find the remainder. Now, what that theorem is saying is that if I substitute a particular x value into this expression, into this f of x, that will get my remainder. So in your JAMB questions, you will see questions like find the remainder when this is divided by that. So what you do is take this x minus 3, equate it to 0, so you can get a value for x, so that x will be equal to 3 here. So you now say that f of 3, you substitute that 3 into this equation. That becomes 3 into bracket 3 to the third minus 2 into bracket 3 raised to power 2 plus 5 into bracket 3 minus 2. So f of 3 will be equal to 3 into bracket 27 minus 2 into bracket 9 plus 15 minus 2. So f of 3 will be equal to 27 times 3, that is 81. 81 plus 18 plus 15 minus 2. So what we have is this minus this is 13 plus this 9, 89, 99 rather. 99 plus 13. So 99 plus 13, that is 112. And that is our f of 3. So this is the remainder. So the remainder is equal to 112. You see, from this expression, it shows that the remainder we're going to get is 112. Now let's solve some standard questions under remainder theorem. Let's solve a question like this says that find the remainder when 5x cubed, find the remainder when this f of x is equal to 5x cubed minus 4x squared minus 3x plus 6 minus 3x plus 6 is divided by x minus 2. So this is a JAMB question. It's very simple. So say x is equal to, just say x minus 2, equate it to 0 so that x will be equal to what? X will be equal to what? 2. So you now say f of 2 will be equal to, substitute 2 into here. So you have 5 into bracket 2 raised to power 3 minus 4 into bracket 2 raised to power 2 minus 3 into bracket 2 plus 6. Now, 2 cubed, that's 8. 8 by 5, 40. Minus 4 by 2 squared, that's 16. Minus 6 plus 6. So we have this minus this, that'll be 24. F of 2 equal to 24. You see, as quickly as I can find the remainder without having to divide. Now, this does not mean that if you divide, you will not still get your answer, but dividing will take a longer process. Do you understand? So that's all about remainder theorem. That's all about remainder theorem. The other thing you can use it to do is now find, now I'm going to solve other questions. Let me see another jump question here. Now, this one says that, this one says, to find it says when the polynomial f of x equals ax raised to power 3 plus bx squared minus 7x minus 6 is divided by x minus 1. This is a GSC question. The remainder is minus 10. And when it is divided by x minus 3, the remainder is 36. Find the values of the constants a and b. All right, so let's attempt this question. It says that when that polynomial is divided by that, let me clean this up. So when this polynomial is this, which is this, so given that f of x, given f of x is ax raised to power 3 plus bx squared minus 7x minus 6 is divided by x minus 2. So it's being divided by x minus 2. This is the divisor. The remainder is minus 10. So what do we do? Let's equate this to 0. X equals x minus 1 equals 0. So x equals 1. Is that okay? So we now say that f of 1 definitely was what gave us minus 10. And what is f of 1 when we substitute here? We'll say that f of 1 will be equal to a into bracket 1 raised to power 3 plus b into bracket 1 raised to power 2 minus 7 into bracket 1 minus 6. This was what gave us minus 10. Do you understand now? So I substituted 1, and from remainder theorem, we know that f of x will give us r, so f of 1 should give us minus 10. All right, so with that, we have that a times 1 cube, which is 1, a times 1 is a, plus b minus 7 minus 6 is equal to 10. So here we have a plus b minus 13 is equal to 10, so that a plus b is equal to, this goes there, that becomes a plus b is 23. All right. Then it says, and when it is divided by x minus 3. So in the same way, we'll say that x minus 3 is equal to 0, and x will be equal to 3. So we'll look for f of 3. F of 3 is said to give us what? The remainder is 36. F of 3 gave us 36. So it means that that a into bracket 3 cubed plus b into bracket 3 squared minus 7 into bracket 3 minus 6 give us 36. Do you understand? So we now have 3 cubed, which will be 27 times a, that will be 27a, plus 3 squared, 9 by b, 9b, minus 7 by 3, 21, minus 6 equals 36. So from here, we now have 27a plus 9b will be equal to, this will be minus 27, minus 27 goes there, becomes plus 27, and that will be plus 27, that will be 63. So let's make this equation 1, and let's make this equation 2. So we'll now resolve by systems of equation. So we can use substitution method. So, and how do we do that? We have our equation 1 to be a plus b is equal to 23, equation 1. And 27a plus 9b is equal to 63, equation 2. So what do we do here? We make a subject here from 1. We know that a will be equal to 23 from 23 minus b. So we solve this into 2. So we have that 27 into bracket 23 minus b. Let's reduce equation 2. Let's reduce it. Let's reduce it. Recall that 27a plus 9b gave us 63. I think 3 can divide throughout. So if 3 divides throughout, we have 3, 3, 3. Here we have 9a plus 3b equals 21. 3 can still divide again. So that is 9 can divide throughout. Okay. So here we have 3a plus b equals 7. All right. So this is where we have. So these are our new equations. So let's call this equation 3. So now substitute 23 minus b for a in equation 3. This is our equation 3 now. Now substitute that for a. So 3 into brackets, meaning that anywhere we find a, we'll put 23 minus b. So 3 into bracket 23 minus b, then plus b is equal to 7. So we now have this by 23. That's 69 minus 3b plus b is equal to 7. So this will give us minus 2b, 69 equals 7. Minus 2b is equal to minus, this guy goes there, minus 62. So we have b will be equal to 62 over 2. That will be minus minus. They take care of each other. You understand? So that becomes here 1, here 31. So b is equal to 31. So recall that a is equal to 23 minus b. So a will be equal to 23 minus b is now 31. So a equal to minus 8. Minus 8. So we have found the constants a and b. And so that will be it for remainder theorem. Let's go to the last one, which is the factor theorem. Factor theorem. Now, the factor theorem. The factor theorem is this simple one here. In the factor theorem says that a particular divisor is a factor of a polynomial if it divides that polynomial f of x. So we say that the particular divisor x minus a is a factor of this if it divides this polynomial and produces another polynomial p of x plus 0 as the remainder. Do you understand? Remember that in the other case, to produce a particular polynomial q of x plus r divided by this same thing as the remainder. All right. So here there will be no remainder. That's just the case. Or 0 is the remainder. That's what the factor theorem says. So another example is show that x minus 2 is a factor. Show that x minus 2 is a factor of the polynomial 2x cubed minus 2x squared minus 17x minus 10 plus 17x minus 10. Let me verify that. Okay, that's plus here and minus here. Then minus 10 or plus 10. Okay. All right. So look at this question. It says we should show that this guy is a factor of this. We know that we can just easily say that x minus 2 is equal to 0, so that x is equal to 2. So we now say that f of x should give us 0, right? F of 2 should give us 0. That's the case. So f of 2, let's test that. Here will be equal to 2 into bracket 2 cubed plus 2 into bracket 2 squared minus 17 into bracket 2 plus 10. So here we have 2 cubed 8, 8 by 2, 16 plus 2 squared 4, 2, 8 minus 17 by 2, 34 plus 10. So here we have 24 here minus 24 here. That's 0. So you see that? Or you can easily prove by dividing. You can easily prove by dividing. Let's use the division principle that we learned the other time. X minus 2, you have 2x cubed plus 2x squared minus 17x plus 10. So pick the first one, divided by this, you get 2x squared. 2x squared multiplied by this, 2x squared minus this by this, 4x squared. By the time you subtract, 2x cubed rather. This takes care of this, and we have plus this minus is that's plus, that's 6x squared minus 17x plus 10. And now say x divided by this again, it gives us plus 6x. Plus 6x times this will give us 6x squared. You subtract again. But before that, you multiply again by this. This by this, that gives minus 12x. And then you have this gives us 0. Minus this is that's minus this plus this, that gives us 5x plus 10. So you now do this again. 5 in this gives us x in 5x, that gives us 5 plus 5. Say 5x times this minus 10. All right, so by the time you do this, you get 0. So you see, you have shown that this guy is a factor. All right, so now let's solve some JAMB and GSE question under factor theory. It says that given that x squared minus 3x minus 10 is a factor of f of x is equal to 2x cubed minus 7x squared plus ax minus b, plus b rather, where a and b are constants. Find the values of the constants. Find the value of the constants. And hence factorize f of x completely. Okay, this one further says that we must factorize completely. All right, so how do we do? Factorize completely means get all the factors. Get all the factors. So it says that guy is a factor of this. So if this guy is a factor of this, let's see. It says that that guy x squared minus 3x minus 10 is a factor of that. It means that let's get what factors are here first. What's the root of this quadratic equation first? And how do we do that? Let's factorize this. Let's equate it to 0 and factorize. So by the time we factorize, or maybe you don't even equate it to 0 yet, just factorize first. How do you factorize? We have 10, 5 and 2. So we have x minus 5x plus 2x minus 10 is equal to 0. So you factorize completely, and we have x into bracket x minus 5 here plus 2 here. So our factors are x minus 5 and x plus 2 is equal to 0. So it means that our factors, the two factors are x minus 5 and x plus 2. Those are our first two factors. Since it says you should factorize completely, but it says also that that guy is a factor. So it means that f of any of these guys here should give us 0. So x is either equal to 5 or x equal to minus 2. Do you understand? So when x is equal to 5, so f of x should be equal to 2x. We said f of x was 2x raised to the power 3 minus 7x squared plus ax plus b. That is what is given in the equation. So you now come here, x is, you now substitute given the remainder theorem. So f of x will now, f of 5 will now be equal to 2 into bracket 5 raised to the power 3 minus 7 into bracket 5 raised to the power 2 plus a into bracket 5 plus b. This should give us 0 if it's a factor. Alright, so we have 5 cubed, 525, 125. 125 by 2, 250. 250 minus 5 squared, 25. 25 by 7. 25 by 7, that's 25 times 5 is 125 by 50, 175. So 175 plus 5a plus b is equal to 0. Is that okay? So this minus this will give us minus 25. Okay, no. Okay, 150 minus this, that's 100, then minus 2. 150 plus 25, so minus 25 again. That will be 75. Okay, yes. So 75, so that will be minus 7. That will be 75 plus 5a plus b is equal to 0. So we have that 5a plus b is equal to minus 75, equation 1. Then when x is for x equals minus 2, we have that f of minus 2 will be 2 into bracket minus 2 cubed minus 7 into bracket minus 2 squared plus a into bracket minus 2 plus b should be equal to 0 given the factor theorem. So we have minus 2 cubed will give us minus 8 times 2 minus 16. Minus 2 squared, 4 by this minus 28 plus, that will be minus 2a plus b equals 0. So from here, this and this will give us 44. So 44 will go there and be positive. So we have minus 2a plus b equals 44. All right. So we'll now come up here. This will be our equation 2. So let's solve by system of equations. So we have equation 1 was 5a plus b is equal to minus 75. Then the second equation is minus 2a plus b is equal to 44. Plus b is equal to 44. Right, we can easily use the elimination method here because we have one of the variables equal up and down in both equations. Equation 1, equation 2. So we can eliminate using what? Subtraction. So subtract 5 minus this, that will be 5 plus this, that will be 7a equals minus this, that will be minus 911. That will be minus 119. So you divide both sides by minus 119. Minus this, minus this. So we divide both sides by 7. So that a will be equal to 7 here. We have 1 remainder, 4, that is 7. The answer is minus 17. A is minus 17. Then sub minus 17 for a in equation 1. So equation 1 is 5a plus b equals minus 75. This is equation 1. So anywhere we find a, we'll put minus 17 that we have gotten for it. So that will be 5 into bracket minus 17 plus b equals minus 75. 5 times 17, that is 85. Minus 85 plus b equals minus 75. So we have this will go there, and we'll have b equals minus 75 plus 85. That will be 10 equals 10. Okay, so that's the answer, A and B. Okay, now says, and find the value of the constant and factorize f of x completely. Okay. It says we should factorize f of x completely. So what we'll now do is we'll now divide. You understand? We'll now divide. All right. So how do we divide this? So we simply say that our guy, since we have gotten the values of it, so it means our polynomial f of x is now 2x cubed minus 7x squared. Now a is minus 17, so that will be minus 17x. B is 10, that will be plus 10. All right. So we want to divide that by, now we are going to divide by this guy, so that we'll get the last factor. So divided by x squared minus 3x minus 10. So we'll come here. We have x squared minus 3x minus 10. So we use it to divide this guy. So you come here, x squared in this guy will give us, so just say 2x cubed over x squared. So it remains 1, and you have 2x. So 2x times this, we have 2x cubed. 2x times this, we have 6x squared. 6x squared. Then you have this times this will give you 20x. 20x. So this gives us 0. Then minus this, minus this plus this. That is minus x squared. Then minus this, minus this, plus this. That will be 3 plus 3x plus 10. And if further go on to divide this in this, will give us minus this in this will give us 1. Do you understand? Because it's the same. X squared cancels x squared. Minus x squared over x minus 1. So you have minus 1 multiply this. Minus x squared minus or plus 3x. Then minus this times minus this will give us plus 10. So by the time you now subtract, you have this, all of this will give you 0. So it means that the third factor, or all the factors are, we have initially gotten two factors, which are x minus 5, x plus 2. Then the third factor is 2x minus 1. And that is our final answer. Right, that will be for this video. Do not subscribe to the channel. And that is my second Christmas gift for you. Then the bonus I talked about was the fact that that I said I was going to give you at the end of this video is a prayer point. And that is that God is going to help you to pass your exams. Ace your exams well. The exam for which you're preparing, ready to watch this video. Do want to subscribe to the channel and share the content with your friends. Thank you.